Numbers, categories, labels. It can get confusing, right? But not with label encoding. This simple yet powerful technique helps convert categorical data into numbers, making it easier for machine learning models to understand and process. Welcome to day 25 of the 30 Days of Machine Learning series. If you're just joining, don't worry. You can click right here to access the full playlist and catch up on every step of the journey so far. And hey, make sure to hit that subscribe button so the next video in this series drives straight into your feed. In this video, we're diving into the world of label encoding. We'll explore what it is, how it works, and when to use it in your machine learning projects. Spoiler alert, it's super easy and incredibly useful. All right, first things first. Let's bring in the heavy hitters. Pandas for data handling, NumPy for calculations, Matplotlib and Seaborn for stunning visuals. Time to load our dataset. With just one line, Pandas grabs the data, and Head gives us a quick peek at the first few rows. Some columns have too many missing values, so let's clean up. Dropping alley, pool QC, fence, and misc feature keeps our dataset neat and useful. Let's visualize our dataset and uncover some patterns. First, we plot the sale price distribution. This helps us see how house prices are spread out. A smooth KDE line shows us the overall trend. Next, we check the lot area distribution. Understanding land size variation can reveal useful insights about property pricing. Then, we explore MS zoning distribution using a count plot. This tells us which zoning categories dominate, giving context to housing regulations. Moving on, we analyze street type distribution, a small but essential factor in property valuation. Now, a box plot of overall quality versus sale price. This helps us see how quality affects pricing. Better quality often means higher prices. Finally, the heat map of feature correlations. This is where we spot relationships between different variables. Strong correlations can hint at key influencing factors in price predictions. Time to handle categorical data. First, we grab all object type columns. Let's check their values before encoding. This helps us see what needs transformation. Bringing in Label Encoder from Scikit-Learn. We'll store encoders in a dictionary to keep track of transformations for multiple categorical columns efficiently. Now we loop through each categorical column, encode its values into numbers, and store the encoder for future reference, ensuring consistency in transformations. Let's check the magic. Our categorical columns are now numbers, clean, structured, and ready for machine learning. A quick preview confirms the transformation. Time to split our data. We separate features, X from the target, Y, drop unnecessary columns, and divide into training and testing sets, ensuring a reliable model evaluation. A 20% test size keeps things balanced. Let's normalize our numerical features. We bring in standard scalar to standardize values, ensuring all features have equal influence. First, we identify numerical columns, then scale X to train using fit transform, and apply transform on X to test, preventing data leakage. This keeps our model stable and improves performance. Let's build our model. We're using a random forest regressor, a powerful ensemble method. With 100 decision trees, it captures complex patterns. We train it on X-train and predict house prices on X-test. Time to evaluate. Mean absolute error, MAE, shows average prediction error. Mean squared error, MSE, penalizes large errors, and R2 score tells us how well the model explains variance. And that's a wrap. We cleaned the data, encoded labels, scaled features, built a model, and evaluated its performance. But what do these metrics really mean? How do we interpret MAE, MSE, and R-squared in real-world scenarios? In the next video, we'll break down evaluation metrics in depth, why they matter, and how to choose the right one for your model. Click on the screen to continue, and I'll see you there.